So in this question, an infinite plane is described by two variables, x and y. Usually, when you're first learning about infinite sheets of charge, they describe a sheet in terms of like one variable, like x equals 5 or y equals -2. And from there, you can easily tell your normal vectors. Your normal vector is something you're going to need to plug into the formula for the electric field for an infinite sheet of charge, which is given by this guy. So if you're given a plane described by two variables, how do you find an here? Well, as a reminder from calculus before, you can find the normal using the gradient of the function over it's the magnitude of the gradient of the function. So first you have to arrange this equation of the plane in terms of x and y. So just shift this 5 over to the left side of the equation, so you'll get a function like this. And just so happens that you can find the normal vector from the gradient of your function of x and y over its magnitude. Once you work it out, that turns out to be 1ax plus 2ay over root 5. So if you were to draw the graph out just on the y-axis plane, if this is your y and this is your x, I'm going to use another color here. You'd find that your line would look something like this. It would intersect at y equals 5 over 2 and x equals 5 here. But note that we want to find the electric field at this point, -1x, 0y, and 1z. So if we look at what this plane would look like on just the xy axis, we'll notice that the point we care about is actually on this side of the line. It's a point -1, 0, and 1 in the z direction. So it would be somewhere around here. And that means we want to find the normal vector to this point, right? So we don't want to find this guy. We don't want to find that normal vector. We actually want to find this. All right. So that means we have to basically take the negative of this. So the effective an we're going to use is going to be -an, which is just going to be a negative in front of your 1 over root 5 ax plus 2 over root 5 ay. So then your final answer is going to end up being in the form electric field is equal to plugging in the rho s given to us here. It's going to be 6 times 10 to the -9 coulomb per meter squared over 2 times epsilon naught. And now for an, you're going to plug in this one, which is -1 over root 5 ax minus 2 over root 5 ay. And your final answer should look like -151.7 ax minus 303.5 ay. And because we put things into SI units here, the units here will end up being in SI units as well, volts per meter. And that's how you deal with that situation.